Well, as you all heard, I'm from Omega Point. That's a company in Sweden, a consultancy firm. We specialize in the crossing between application development and security. And who are you?
I'm also Daniel, but I'm from a different company called Avanza. We're a Swedish-based internet bank and stockbroker. And to give you an idea, we're the biggest actor on the Stockholm Stock Exchange in terms of trade. And I do a lot of software development and security stuff on that company. But that's enough about us. If you want to know more, just use Google.
All right, so this talk today is about cracking the code. So what's really that about, Daniel?
Okay, so what are we trying to crack here? The thing is, Daniel and I have been working together for many years. And one thing that we've been thinking about is that it tends to be really, difficult to create secure software for some reason, for the typical developer and typical company. And we try to figure out, why is it so hard? Why is it that we have all these security flaws everywhere? And it turns out one reason that we think is that, when you're a developer, you're all in, you got your backlog, you got so many business features that you need to implement that you don't have time to think about security. Right? Or maybe you're not interested in it.
So that makes perfect sense, because no matter how much you try, you still get pawned by somebody in a black hoodie, right?
Yeah.
That's the normal case. So it sounds really promising that we could. Are you saying, like in Secure by Design, they're claiming that it's supposed to be a mindset to create secure software, right?
Exactly. So the Secure by Design is based, that concept is based on the fundamental idea that what if we can use, just sound and very good software design principle that will give you kind of security as a positive side effect, right? So we can focus on designing good software, which we all love because we're developers, and then your software will become more secure just by following a couple of guidelines. And that's really the essence of Secure by Design. And today we want to talk about a couple of those things that are the topics in Secure by Design. We'll scratch the surface, so to speak.
So one thing that we will do is that we will actually look at a real security problem, and then we will look at, I guess, a bug, a classical bug, and we will try to fix that bug by using design. And then we will apply that same design pattern on, the security problem. And by that, we have sort of, tested our hypothesis of dealing with security through design, right?
Yeah, to see if these concepts actually works, and not just in theory. And we'll move on to look at a different type of security problem, which kind of comes from the fact that you have to deal with mutable data, right?
Right.
And we'll try to see if we can solve that by making immutability immutable.
Is it immutable? Mutability.
Yes,
That's
a tongue
a fun
twister.
topic. Yeah. Okay. And then there's a third thing that we all encounter every now and then. It's called GDPR. Anyone heard of that? Okay, a few hands.
Keep track of your information and don't leak it.
Yes.
So we'll see if we can find some kind of design principle that will help you detect if you accidentally leak data, or maybe if you're leaking passwords into log files and stuff like that.
Right. Okay, so let's dive into the first classical security problem. So what's this, Daniel?
This is like the textbook 101 web security problem, cross-site scripting. How many have heard of cross-site scripting attack? Yeah, it's very fundamental. So we just run through what it means. Let's say you have a web page here with a form that you can enter, in this case, a phone number. Mm-hmm. But instead of entering a phone number, some evil person will enter a little script tag, in this case, a JavaScript tag, code that says it will pop up an alert box. Okay, right. So the whole cross-site scripting attack, what happens then?
Well, there we go. So what happens is that of course, you take that input, and now this is the evil input that gets stored in some sort of database, and it eventually gets rendered on a web page, and it gets interpreted as code, right?
Yeah. So the browser will turn out to render that as JavaScript and show an alert box, and of course in the reality it's not going to be an alert box, it's going to be some kind of malicious JavaScript code.
So I guess you're safe if you don't store in a database.
No, not really. I mean, there are variations of this. Of course, in this example, it's a reflective cross-site scripting where basically you do some input validation, and you say, this is bad data, we're not going to accept this, so we're going to throw an exception, and we're going to include the data in the exception message, and then for some reason that error message is displayed to the user, and you get the same problem again. The browser might end up rendering that or interpreting it as JavaScript code and actually running the code.
So everyone in here agrees that this is simple, this is 101 security problem, but this is not really the one that we're going to attack. This is the one. And this is the second order cross-site scripting. And that's a little bit more nasty, because as you see here, I guess you take that bad data and shoot it to your service that's inside your trust boundary, right?
And you fix this service, so it's safe. It's not, you don't have cross-site scripting there, and you're in your world, you're safe. And for some reason, maybe you got that error message and you log it, of course, you gotta log your errors. But then some other guy is sitting over at the, I don't know, the sysadmin group has this log tool to check logs, and it's browser-based. And maybe that browser ends up running that JavaScript code.
And if you look at this, you see that the difference now is that our log analyzer reader tool here is inside of our trust boundary. So the attacker doesn't focus on the primary system, but rather on the secondary system. And they do that through, classical cross-site scripting.
And of course, this is much cooler because the admin person is probably going to have a lot more access if you hijack their computer.
Yeah, I wonder if that could ever go wrong.
No.
No. Okay, so if you look at this from a technical perspective, how would we address this? Well, the classical thing is that the data gets rendered as code, right? So we should escape it. Isn't that what we do?
Yeah, we forgot to escape. In the case of displaying it in a browser, we just forgot to HTML escape it. If you do that, you're kind of safe.
Yeah.
Then the browser knows that this is not JavaScript. It's just we're going to display it as text. So I guess the solution is to just make sure that let's escape it.
Right. But the thing is that, really, how do we know? The thing is that in a second order attack, we don't really know that we are going to have, what kind of tool is it that's going to analyze it? So whose responsibility is it to escape that data? Well, as it turns out, that needs to be communicated and fixed that way.
Yeah.
Right?
So we'll come back and see how we can solve this cross-site scripting bug with a couple of interesting design principles. Yeah. Let's take a look at a different thing. This is, I guess, a classical bug, you would call it. In this case, a web shop where you can buy books. And the interesting part is that this is based on a real story, so to speak.
Yes.
Where a big multinational company selling stuff on the internet. They weren't selling books, though.
We can't really reveal their names, but they were making, well, let's say they had revenues of billions.
But the interesting part is that they had a little bug. We ended up, and a couple of customers noticed this, that you could add books to the shopping cart. And at the end, you can just tweak the request, and you can add a -1 book.
So wait a minute, are you saying that, so they bought one Secure by Design, that's $49.99,
Hitchhiker's Guide to the Galaxy, and then they added a negative Hamlet.
So they gave themselves like a discount of $40. So it's $39.49, that's a more reasonable price, right?
It's pretty sweet. It's like a do-it-yourself discount. And they lost a lot of money before they noticed this. And as a side note, once they fixed it, they decided not to pursue any customers that did it because it was bad. But the interesting part is that you had a bug that you lost a lot of money.
So let's look at this from a more philosophical perspective, right? We can look at this from a context perspective.
Yeah. So what the developers did when they built this system is that we need to represent quantity of a book or an order item. Mm-hmm. What's a quantity? Well, it's a number, 1, 2, 3, 4, 5, 6, should be an integer in your code, right?
Makes sense.
So what's the problem with having quantity being an integer?
So if you look at the left here, we have the math context. We are applying the math context in our web shop context. We're saying, an integer from that context into this context is perfectly fine because we represent quantities as integers.
Okay, so let's take a closer look at the mathematical context. What does that say about integers?
Well, if you remember your math from back in the days, integers, they form an abelian group. To be honest, they also form an abelian ring because they're closed under both addition and multiplication. They're actually, if you pick two integers and you add them, you get another integer. So you remember that? There are some other rules you can do, like you have an identity, you have an inverse, and commutativity.
Okay, so I gotta admit, I don't really remember that math from school. I don't know what I did, but what I do understand is that what you're saying is that a quantity doesn't really behave as an integer.
Okay, how do you mean?
So like a quantity is not supposed to be negative, or you can't unbuy a book. And I guess if you take, you can't do mathematical operations like a quantity times a quantity. What's that? Quantity square. So it doesn't really make sense to have quantity as an integer.
Yeah, it is kind of weird to say that quantity is an integer. I mean, it really isn't an integer. It sort of looks like an integer, but it isn't an integer, right?
But if you ask any business analyst or business person, he or she is going to say, well, it can't be negative. It can't be more than 200 because the shipping department can't handle those large orders. So what we should do instead is we should represent quantity as something other than an integer in your code.
So you're saying quantity is really quantity?
Yeah, it's an important concept in your business domain, and you should represent it as a domain primitive, that we call it. So what's a domain primitive? Well, it's an extension of value objects in domain-driven design. I don't know how many are familiar with domain-driven design and value objects, all right? A couple of you. But for those who aren't, a value object is essentially something in your code or in your model that represent an important business concept, in our case, a quantity. And a value object is only defined by its value.
So as an example, that would be like money?
Yeah, money. If I owe you $10,
right,
then it doesn't matter which $10 bill I will give Daniel, as long as it has the value of $10, right?
Oh, wait a minute. As long as it is $10.
Yeah.
The preciseness there is very important, right? I don't expect $9. Well, I don't even expect $11, right? I expect $10.
Yeah. So basically, a domain primitive is an extension of a value object where we say not only is this going to be immutable and it's going to be represent an important concept, it's also going to have all the business invariants within it, so you know that if this domain primitive exists, it's valid. Otherwise, the object can't exist.
So that's pretty nice. That means that if we have an object that is represented as a domain primitive, we know for a fact that it is valid
in your current domain, right? So
That's
you never have
nice.
to check, is it positive number, is it below 99, and so on. You just know that you have this quantity object, it's valid. And that's essentially what a domain primitive is.
Okay, so this is really abstract. Let's look at code.
Yeah.
Okay.
So when we implement the quantity in this case, we create a class that could look something like this. It's immutable, right?
Mm-hmm.
They probably had a couple of getter and setters down here. And it upholds all the business invariants at the point of construction, which is important because that means if you have a quantity object, you know that whatever rules there are applied on this are fulfilled. In this case, between 1 and 99.
So that means that this is not really the generic concept of quantity even. It's very specific to that particular context where it's used.
In this current web shop, that's where this quantity is valid.
Because the shipping department can't ship more than 99 books in an order. Okay, that sort of makes sense. Okay, so if we go back to our philosophical reasoning again, if you look on the left with the math context is, we have the integer of -1. What happens if we try to inject this into our web shop now?
Well, obviously, if -1 comes flying, you're not going to be able to create this object, so it's just going to fail. It's going to end up being a bad request or something, but it's not going to enter the system. And the same goes if you try to enter something else, like text, random text, and so on.
So you're saying that if we have quantity inside of here, we know for sure it's going to be a number between 1 and 99.
It's no longer just an integer.
By definition.
Yeah.
So that's super interesting because now you can see that domain primitives, they will tighten your design.
Yeah.
Right?
And it will make your code more robust because you're not going to have data that is invalid, and it's easier. It lowers the cognitive load on you as a developer because you don't have to think about those details anymore when you're using quantity. So the thing is, can we take this concept of domain primitives and apply it on our code base and kind of implicitly fix the cross-site scripting attack?
I don't know. Let's see.
Yeah.
What do you know? Okay, so to rehash, this is the good phone number. That's fine. But when we try to enter the bad input, well, that's bad. We don't want that. So the question now is, if you look at the code inside, in the service, you find this register method, and it, So how should we deal with this now?
Yeah, if we zoom in on this, it looks like this currently. And as a developer, you're probably going to look at the variable or the parameter name, right? It says phone number. Mm-hmm. So I know when I'm coding away, it's a phone number. It's supposed to be this and that, and I can do these operations on it. But the problem is an attacker is not going to look at the variable name. She's going to look at the type. Yeah. Yes. And what's a string? What can a string be? Like pretty much anything, right?
I think the length is about this.
Yeah. It's huge. It's supposed to be this, a quantity, but the string can be this. So what if we replace the phone number with our new domain primitive called phone number? Then it's going to look like this.
So now the interesting part here is that we have modeled something that is an explicit concept in our business domain. We have not thought about cross-site scripting. Remember that. We're thinking about phone number. And if this was a super good language, this is Java. This is quite old. We could actually have only saying, I accept phone number. But now you have to have a variable like this, right? That's fine. But this particular type or class now, it only accepts the specific phone numbers that you expect in your context. For instance, it could be phone numbers that are only, I assume there's a local phone number here in Krakow, right? Some area code here. Or it could be in Poland or maybe Sweden or something. It might not be every phone number there is in the world. Even though if it is every phone number in the world, we would have specific rules associated with what is a phone number, right? Interesting. So now the code became a lot more explicit, right?
Yeah.
Mm-hmm. Okay, so domain primitives, they prevent cross-site scripting.
Well, they kind of implicitly prevents it, all right? As Daniel mentioned really fast here, we never focus on trying to fix a cross-site scripting attack. We were focusing to be very strict and specific in our business domain, and as a side effect, we kind of harden your code and your system to not allow that bad data.
So you're saying that if our domain rules still accept, script, alert, well, you can still inject that.
Yeah, of course.
Okay. But do I need to do my escaping, by the way?
You still need to do that. We're not saying that you're going to replace this going to replace, the every other solution that you have. But what you're building is kind of security in depth. All right, you have multiple layers. You're still doing the escaping, and hopefully your framework will do that for you, so you don't have to think about it. But you also start to get very strict and robust code that will additionally help you to prevent all kinds of attacks that you didn't even think of.
So you're saying that if you only rely on the escaping that's provided by your favorite framework, if they do an update and they have a bug in that, and you haven't done any other security measures, well, you're going to get vulnerable, right?
Yeah.
But if you applied domain primitives as well, you need to breach the validation from a domain primitive, and then you need to exploit the vulnerability that appeared in your favorite framework.
Yeah. So again, the interesting point here is that we're focusing on actually evolving your software and making sure your software does what it's supposed to do from a business perspective.
Right.
That's what you're focusing on, because that's your main task, right? Implementing features. And as a positive side effect, you actually hardened your code and added security in depth.
But I think now everyone gets this, and they go like, yeah. But honestly, if I need to render all my concepts as specific domain primitives, doesn't that, create a lot of classes?
Well, it could, but if you end up having a lot of domain primitives, that's just an indication that you have a lot of important concepts in your code. Remember, you're focusing on the important things there. And if you have so many important concepts in your business domain, well, then you kind of have to deal with it, and making those concepts explicit actually reduces the complexity for the developer when you're coding and reasoning about everything.
Oh, so by using strings and other generic data types, we're just hiding the complexity.
Yeah.
Okay, so we don't really get rid of the complexity by using those generic types.
No.
Okay. Wait, okay. I've learned that creating objects is expensive, right?
Yeah, it can be, but it also kind of gives away your age. I mean, it used to be expensive. I don't know, Java 1.1.
1.1. Yeah, that was a while ago.
Yeah. The thing is, like in any modern JVM, at least in Java, is it's not really that expensive. So you don't have to worry about creating short-lived objects or objects in general. And of course, someone's going to say, well, I'm building this system that has really high demands and low latency and stuff like that. Well, yeah, in those cases, maybe you shouldn't use this. But my experience is that when you're building those kind of systems, it tends to be a very small portion of your entire code base that actually needs to have this super low latency or performance. So there you can use the low level language primitives, but in the rest of your code base, focus on being clear and building bug-free and easy to read code.
Isn't those places where you actually do your bit shifts and those kind of things?
Yeah.
Yeah. Okay. So in 99.9% of the cases, well, this should be okay to use. Interesting. Okay. So now we've seen that we could actually apply, design and focus on our business and our domain rather than security, and get security as a benefit. And that's pretty nice, because now we as developers can actually implement secure software. But now the question is, are there any other design patterns that we can use to fix other things?
Of course, there are many. One thing that we always do is that we need to manage, changing data. We need to manage, we need to mutate data. And what's the problem with mutating data from a security perspective?
Well, if you think about this, if you have mutatable data, that can be mutated from many parallel sources, right? And you need to make sure that consistency is achieved.
Yeah.
And that affects, in turn, your availability, right? Because you need to block. Or how do you prevent it otherwise?
Okay, so I guess in code, if you have something that is mutated by multiple threads, you need to lock, synchronize.
Right.
And that can potentially slow down your program and make it less available.
Yes.
But what does availability sounds cool from like scalability point of view? What does that has to do with security?
Okay. So what we now need to look at is something from information security, and they have an acronym called CIA.
Oh, like the Trump CIA?
No, not Trump CIA.
No?
We've got confidentiality, integrity, availability.
Okay.
And confidentiality is really about, making sure that you don't disclose data to non-authorized users, for instance.
Okay, and I guess the integrity part is about, making sure that data is only changed by those who are allowed to change it. And it also means that data doesn't get altered while in transit over internet and stuff like that.
I mean, it makes perfect sense.
So the availability part, again, what does that has to do with security?
Okay, let me give you an example. Let's say your house is on fire.
Okay, bad.
Pretty bad. Okay.
I'll probably call 112.
Yes, but now 112 is flooded by prank calls. So your call doesn't get through.
That could be an issue. I guess people could possibly die in the fire and stuff. So
That's
okay,
pretty serious.
I see the point. That's a security issue.
Yeah,
And the same, I guess, goes for data.
Yes.
If sensitive data or any data isn't available when it's supposed to be available.
That's right. So availability is really a concept that needs to be achieved by a secure system, right? Okay, so let's see if we can combine availability and mutability. That's sort of the toughest thing we can come up with, right?
Okay.
Because how do you scale something that's mutable?
Well, you can, but the more you scale it and the more distributed it is, the more difficult it becomes to try to make it consistent and everything like that.
Right.
Especially if you just focus on the code part, you have to need to deal with all this thread locks and so on.
So now we need to see if we have a design pattern that can address this, that allows us to get it highly available, but at the same time support mutability.
Okay. So let's jump back to theory a little bit, just to understand. In domain-driven design, we talked about value objects, and we understood that if we tweak the value objects so they become domain primitives, we can make our code more robust and more secure. And then you have this thing called entities.
Yes.
And entities is essentially how you deal with let's say, mutating data in domain-driven design. So what's an entity?
Well, in difference from a value object, an entity is really a unique object that has an identity and a lifespan, right? For instance, a customer, right? If you're a customer in a system, I bet you that you will change your address, your phone number, your credit card number.
My age.
Your age
might
yes.
change.
But you're still the same customer. Okay. So the concept of an entity is something that exists in almost every possible business domain. Okay. So the question now, if you jump back to our favorite example, and as you noticed, we have fixed the -1 problem now, so no, it's accurate. Okay. So how would you represent an order?
Well, I guess the order typically can have a lifespan. It's a new order. It's a processed order, a paid order, a shipped order. Okay, so it changes, the data of the order changes. You can add and remove items, but it's still the same order, so it kind of maintains its identity. So I guess I should model this as an entity in my model and in my code.
And usually we model, entities as mutable objects because they need to allow mutation.
Yeah, the data needs to change.
Yes.
So then, as soon as you have a mutable object, you run into all these problems that we talked about, right? How do you handle a multi-threaded environment and so on?
And the funny thing now is that we have a design pattern for this as well. And this is called entity snapshots. And what's an entity snapshot?
The entity snapshot is essentially, what you want to realize is that even if you have the concept of an entity that changes, that its state mutates, doesn't mean it has to be a mutable object in your code. You can represent it as an immutable object, hence making the mutable immutable phrase.
Okay.
So as soon as you do that, you realize that when you mutate, you can't do that on the object. So you kind of have to separate the updating functions and then just the reading functions.
So this is sort of like when you access data over the internet, right? If you try to access a web page, you get a snapshot of that data on that page. It's sent to your browser, gets rendered, and now data can either be changed on the server and you reload, or you would it gets pushed to you, right?
Yeah, exactly. So what you're looking at is an immutable snapshot of the entity at a certain point in time.
Right.
And as soon as you make it immutable and everything, the entity snapshot kind of gets the same characteristics and positive benefits as domain primitives. So it becomes very easy to deal with.
Okay. So, all right. So how does this look now in a conceptual manner, right?
Okay. So basically, you have a read service that you can go to if you want to read the entity, the order. You just get an entity snapshot of the order. Okay. And if you want to change the order, maybe add an item, you can go to the update service. And you can update that.
So now we have separated read and writes.
Yeah.
Okay, I see a resemblance to CQRS here. Okay.
Yeah, the basic concept is very similar.
Okay.
But the difference is in the implementation in code that we'll see. So to make this more concrete and look at code, what are we talking about? If we would implement order as a classical entity, it might look something like this. It's just a simple object. It has an ID, because it's an entity that defines what this is. And then you have a bunch of order items, so you can add items and remove items, right? You can mutate the order.
I mean, it makes perfect sense. The problem now is how do we share this? Exactly.
Then you have to start filling this with some kind of, concurrent code and everything. Yeah. But what if we implement this as an entity snapshot instead? Then it would look like this. Pretty much the same. The only thing is that you can see that now the order items within the order, you can't change those anymore. This entire order is now immutable. It still has the ID because it's not a domain primitive, because it's an entity, but you can only read the data.
But wait a minute, I still need to update the data then. How do I do that?
Then you have to go to the update service. And just before we do that, just like domain primitives, in the constructor, we will uphold all the business rules. So if there are business rules that says, an order has to look like this, you will enforce that in the constructor. So if you're looking at an entity snapshot, you know that it's valid, whatever valid means in your domain.
So that's pretty neat. That means that we're going to have a snapshot of an entity that's perfectly validated like a domain primitive.
Yeah.
Oh.
And in code, it's immutable, so you can just throw it around or share it and pass it,
Cache it, whatever you want to do, right?
Pass it and cache it.
Okay.
Yeah.
Okay. So if you want to update it, you said we need to go to an update service.
Yeah. So you can go to the updating part and say, I want to add an item to this specific order, and it will do that. And that operation is going to be asynchronous, so to speak. So if you want to see the order with the item added, you have to read up a new order. A new entity snapshot.
So you're saying that it's using eventual consistency to, I guess, distribute the new state.
Yeah.
Okay. Well, that's the same thing like the internet. When somebody updates some web page, and if you have to do page reloads, well, eventually everyone will have done the page reload. Okay.
And of course, it's not you kind of pushed all the handling of the distributed update to the infrastructure level. Okay. So it's not a magic bullet that problems disappear, but it disappeared from your code, and that's a very good property. Okay.
Once again, Daniel, what about performance?
Okay, well, it can actually improve performance, depends on your system, but let's say you have a system that is very read heavy, right? Mm-hmm. You read a lot and you update a little bit. If you separate those, the reading and the writing part, the reading don't have to compete with the writing part, so it can actually improve performance.
Okay.
And again, you're probably going to ask, doesn't it become more complex? But since we separated the concerns in our code base, we're kind of following the single responsibility principle and focusing on one thing at a time. So your code tends to be a lot less complex.
So to be honest, there's another benefit. Now, if you try to focus a little bit on the security part again, and that comes to authorization. Not everyone that's allowed to modify something might be, able to read it, or vice versa. Could be that the readers are not allowed to modify it. I mean, that's the most usual case. So you can actually set, authorization rules associated with the services that are responsible for update, and the readers have other authorization rules.
Yeah,
that's pretty nice.
And maybe the code handling the updating part is a different service, totally different microservices. So one microservice can just read. Even if you hack it, you can't mutate it.
Right.
That's another benefit.
Okay, so that's pretty neat. Okay, so entity snapshots, they actually remove many of the issues that we have with mutable state. That's pretty neat. We can actually start getting improved availability because a immutable object is shareable. It's scalable, right? And consistency is achieved through eventual consistency, right?
Exactly. And again, they behave like domain primitives, essentially, so they're safe to use in your code in a multi-threaded environment. You don't have to, once you check, it's valid, so no one can alter it while you're processing it.
So once again, we have really focused on the problems of mutability, which is a technical problem that we, as developers care about. But we got some security benefits, which are pretty neat. Okay, so we have now seen the immutability problem, but now the question comes to the accidental leakage. Leaking out sensitive information is really bad, and that's what hackers love.
Okay, so the question is, can we design our code in a way that will allow us to detect that leakage early on, so it doesn't become a problem?
Okay, so you say accidental leakage. Where would that end up then?
Well, typical causes are the information ends up in a log file that wasn't supposed to be in a log file. Maybe you have some kind of session persistence that you're not aware of. So a certain web service will actually try to persist your session down to a disk.
So how many are using Tomcat? Spring Boot?
Some, yeah.
Okay, some.
The default setting is that if you shut it down, it will write all the sessions down to disk. So what if you have sensitive data in your session, it's going to end up in your disk without you knowing it? That might be a problem. Another cause that is a little bit more subtle is if you have a domain model that evolves, that might cause sensitive data to leak to places it wasn't supposed to.
Okay, that I find very interesting. Evolving code. Yeah. I mean, most systems tend to evolve.
Oh, they're dead.
Otherwise they're dead, right? Yeah. Okay, so let's look at an example.
Yeah, so let's say we have a system with a user. The user has a name, a nickname, and an age. And we decide that none of that information is sensitive, right?
Well, you could argue that these two are actually sensitive, but let's, for the
in
example...
our system, it's not sensitive. So we're fine, we're happy, we can use the user in any way we want. We develop the system, we can write it to logs and then whatever.
Right.
And then at some later point in time, maybe a year from now, we decide, well, we need to evolve the user. The user actually has to have a social security number. Now that turns out to be sensitive data. Now, when we do that, and we're going to implement all new features and everything is going to be great, but we're never going to have time to go through our entire old code base to make sure we didn't write the data of the user somewhere, that we didn't just write the user down to a log, for example. We're never going to have time to that. So what typically happens is that now the social security number is going to be in the log that we thought was safe, that used to be safe.
Okay, so the question now, is there a design pattern we can use to help us detect this kind of flaw? That we have accidentally, starting to leak social security numbers. I mean, we want to get help with that. And believe it or not, there is. Yes.
And we call it the read once object. So basically, let's say we have some kind of data that is only supposed to be read one time in your system. The social security number, you're only supposed to access it once in your business logic. You can create something like this that basically makes sure that you can only get the actual value once, and if you try to get it again, you're going to get an exception. All right,
okay.
That's what this code does.
So you're saying that if we, through our domain knowledge, we have identified that this particular piece of data is only supposed to be, processed or accessed at one location, or it could be multiple locations, right?
Yeah.
And if it's multiple locations, we say it's going to be accessed 4 times, or 1 time, or 2 times, and we will adjust this accordingly, right? But if it's 1 time, we know that it's going to get sent to that other service or used in this equation or whatever it is. And if it's done multiple times, 1 more than we expect, we are going to fail.
Yeah. So for example, if that value is extracted and written to a log, we're not going to prevent the data to end up in the log, but when you're trying to use it in the business sense, it's going to blow up. And probably you're going to notice that very early on, probably in your test suite already. So you can detect these kind of flaws and fix them. And as you can see, we're also taking care of making sure that you're not leaking the sensitive data in the toString method. And we decided to also prevent serialization of this object. So it's very popular for libraries and framework to try to serialize objects on the fly, but now you can't do that. It's going to blow up, and if you want to send this object, you actually have to get the value explicitly and then send it.
I mean, for instance, if you didn't know that Tomcat serialized your session when it was shut down, if you had modeled your sensitive social security number as this, well, that serialization process that Tomcat did would not have succeeded.
Yeah.
And that's pretty neat.
And another use case could be, let's say, a password in the login system. Typically, when you're logging in as a user, you only want to access the password once, right? You enter it, and then you're going to get the password when you're trying to match it towards the stored hashed value, for example.
Right. Okay. So what we have seen now is actually a way for us to detect accidental leakage. And that's pretty neat, because this helps us once again to, discover those security flaws that might just pop up in an application.
And again, we're not focusing on not leaking data, not in the first priority. We're focusing, okay, our business rule says that we're only going to read the value once. Okay, so that's important. We're going to make sure our system can only read the value once. And as a side benefit, you're not going to end up having that data spread all over, and you have this nightmare with GDPR coming up, and you're trying to figure out where all your data is.
Right. Okay, so to summarize, the domain primitives, they are intelligent, tiny machines, right? That are if they exist, they are valid by design, right?
Yeah.
And they actually reduce the attack vector implicitly, because we have decided to focus on things that matter to our business domain, not the fact that it could be a cross-site scripting or whatever it would be, but the fact that we are only accepting what we anticipate in our business. And we have entity snapshots.
Yeah, which is a way to represent entities, immutable data, in a way that will not only make your code easier to reason about as a developer, but it will actually give you a couple of security benefits as well.
Yeah, and of course the read once objects, or read n times objects, they help us to design the fact that we know how it's going to be consumed in our system. And if we somehow violate that presumption, well, we are going to get notified. And that's the beauty of that.
So again, these are all just a couple of ideas that will help you when you're focusing on building your software, focusing on putting out a new business feature. If you have something that is supposed to be a value object, why not make it a domain primitive? You will make it more concise, and as you see, it can actually give you a couple of security benefits. And again, if you're dealing with entities, consider using the entity snapshot pattern. That might get you benefits, not just security benefits, but also stuff like performance benefits.
Yeah.
And ideas like read once objects. These are all just simple tweaks of good design patterns that you can keep in the back of your head and apply to your everyday code. And it's a lot easier, we've noticed, and for ourselves too, when we're working, that it's easier to focus on the business feature because that's closest at hand, and it offloads your internal backlog to think about all the security features. And of course, it doesn't replace the traditional security concepts and practices like firewalls, and we talked about escaping. It's a complement to that, to add the security in depth in your code base and in your systems.
So we mentioned in the beginning that this is part of a broader concept called Secure by Design, and believe it or not, there is a book.
And this is our shameless plug.
Yeah.
Me and Daniel and another guy called Dan is writing a book, trying to put out our ideas around Secure by Design in a book format.
Wait a minute, you said you, me, and Dan? Daniel, and Dan?
Yeah.
Isn't that D? No.
Yeah. So it's
Okay.
a DDD book.
Yeah, okay.
I'm sorry, bad joke. But we actually have discount code for Code Europe. So if you want to have 40% discount, use that code.
Yep.
We're going to put up the slides on SlideShare also,
Yeah.
if you don't have. And it's not just for our book; it's the entire Manning content.
Yes.
Yeah.
And the cool part here is that this book is not printed yet. It's part of their early access program.
It's not finished yet.
No, it's not finished yet. So the minor detail, yeah. No, the thing is that you can read chapter by chapter. So we've written several chapters. They're released. I think 1 through 6 or something like that.
Something like that.
And you can help us, give us feedback on stuff you don't understand or don't agree with, or say, why don't you bring this up as well? And you can help us designing the best possible book.
Yeah, and we really appreciate the feedback. Or you can just buy the book with a discount code and wait until the book is finished.
Yeah, that works too.
Read it once.
Yeah. Read it once. Yeah. Okay. All right. So I think we have a little time for some Q&A.
Yeah. Anyone have
Crystal
any?
clear. Yes.
Okay, so the question is, have we applied this in real world projects? And the answer is yes, multiple times. I would say the last couple of 3 or 4 years.
Yes.
On both greenfield and brownfield projects. Yeah. And we've seen very good results. One interesting project that we were on back when I was a consultant also, we helped a client. They had built a system once, and completely failed, decided to trash it and rebuild it from scratch. And then we came in to help them rebuild it, and we coached the team to use these principles. And at the end, they ran a penetration test, and they only found one minor flaw for the same business functionality that they had implemented earlier, where they found a couple of hundreds security flaws. So I think it's a testament that it actually works on, and the team was not experts in domain-driven design or anything. It's just novice developers and a couple of seniors, but we just put the ideas in their head and say, why don't tweak the code in this way? And then it makes the code more robust, and it actually reduces the overall number of bugs, I would say, not just security bugs, but
I think the
bugs.
funny thing is that, of course, we were really interested in understanding why did we have one security flaw. So we noticed that there was a test that's supposed to have caught that. And we looked at that test, and it had an @ignore on it.
Yeah.
Yes. So we were like, yeah, okay. So we're human. That's good.
Yeah. And I would say, like, of course, every time you start out with a new concept like this, or maybe you read, I don't know, the ideas of clean code, there's always a little, let's say, threshold, before it sinks in. So in the beginning, it might feel like, oh, this takes too much time, I don't have time. But once you get used to it, you just think it's just a regular way of designing your objects, and you just pick subconsciously. Just the same way you would pick a certain data structure because it's more performant than another data structure, and you don't think about it anymore. Does that answer your question? Thanks.
More questions? Yes.
What's the name of this float book?
I'm sorry, we can't reveal. We have an NDA agreement.
Yes.
You mean, oh, so the question was, what was the real company name about the behind?
We can't say.
No comment. So we can't reveal the real company behind the bookshop. I'm sorry.
Make sure you don't try buying our book with -1. No. No. All right.
Maybe you should. Then we can use that as a case study in the
that's
book.
good. Good thinking.
Yeah. You already got a discount.
Yeah. All right. Last one. Anyone?
Okay. If anyone want to just grab us, we're going to hang out at the conference. A couple. If you guys are really interested in the book, we actually have a couple of free codes to give away ebooks. So just come down and you can get that if you're not satisfied with a 40% discount.
All right. Thank you very much.
Thanks.